What did we discover about light that still confuses physics today? Light seems simple at first. It travels, it illuminates, it warms, it allows us to see the world. We take it for granted, assuming it is a thing that behaves the way we expect. Yet when you look closer, light becomes profoundly mysterious. It is neither just a particle nor just a wave, and it behaves in ways that defy simple intuition. It can travel in straight lines, yet it can bend and interfere. It can knock electrons off metal, yet it can pass through tiny slits and create patterns that seem impossible. And even after decades of careful study, the deeper essence of light, the exact way it exists and interacts with the universe, remains confusing, challenging physicists to this day. The thing we think we understand most intimately is actually one of the universe's most subtle puzzles. The reason light is so fascinating is not that it is complicated, it is that it forces us to confront the limits of our intuition. Experiments reveal its strange behavior before theory can catch up. We can predict some aspects with equations, we can measure how it interacts with matter, we can even manipulate it to build lasers, cameras, and fiber networks, but no single description tells the full story. Sometimes it behaves like a stream of particles, sometimes like a wave, and sometimes like both at the same time. This duality is not a failure of physics. It is nature showing us that reality does not always conform to our expectations. Confusion is not a weakness in understanding. It is a sign that we are engaging with the universe honestly, grappling with phenomena that resist simple categorization. Learning about light teaches a larger lesson about science itself. It shows that questions are more important than easy answers. The moment we stop asking, we stop discovering. The fact that light still confuses physicists is not discouraging, it is invigorating. It means the universe is far more intricate than our intuition allows, and it means there is always more to explore. To study light is to learn how to think, how to design careful experiments, how to reason with imagination, how to test assumptions, and how to accept that uncertainty is part of truth. Every experiment that produces a puzzling result is an invitation to think differently, to follow nature's clues without shortcutting the process with comforting explanations. Even the most brilliant minds have found themselves humbled by light. Its behavior forces humility because it is a reminder that reality is not obligated to make sense in human terms. The lessons extend beyond physics. They teach curiosity, persistence, and the courage to embrace confusion. To study light is to experience the excitement of not knowing and the thrill of discovering something new through careful observation and reasoning. The discomfort we feel when nature refuses to fit neatly into our categories is the same discomfort that drives progress. It is where real learning happens. So the discovery about light that still confuses physics is not just a fact about photons or waves. It is a lesson about how to approach knowledge. It tells us to remain curious, skeptical of easy answers, and brave in the face of mystery. Every flicker, reflection, and interference pattern is a reminder that the universe is richer than we imagine, and that science is not about closing the book on questions, but about opening it wider, observing closely, and thinking deeply. Light teaches us that confusion is not a failure, but a signal that we are on the edge of understanding, and that the pursuit of knowledge is always more exciting than the comfort of certainty. Light is one of the most familiar phenomena in our daily lives, something we often take for granted, yet it is also one of the most perplexing and mysterious aspects of the universe, because the more deeply we examine it, the more it defies our ordinary intuition and challenges the way we think about reality itself. At first glance, light seems simple. It travels in straight lines. It illuminates objects. It allows us to see color and shape, and it can be reflected, refracted, or absorbed in ways we can predict and manipulate. We measure it with meters and seconds, describe it with waves or photons, and build technologies like cameras, lasers, and fiber optic networks around it, giving the impression that we fully understand it. Yet as scientists have discovered over centuries, light refuses to be confined to a single description. Sometimes it behaves like a wave, spreading and interfering in patterns that appear impossible for particles. Sometimes it behaves like a particle, colliding with matter and transferring discrete amounts of energy in ways that waves alone cannot explain. This duality is not a minor curiosity. It is a fundamental property of nature that has baffled even the most brilliant minds and continues to challenge physicists today. Experiments, such as the famous double-slit experiment, reveal interference patterns that suggest light travels through space in ways that do not conform to common sense. Yet, when observed directly, it seems to arrive as discrete particles, demonstrating that the universe operates on rules that often contradict everyday logic. The confusion does not stop at duality. Light also exhibits behaviors that depend on the frame of reference, the interaction with matter, and the conditions of measurement, showing that what we perceive as reality is inextricably linked to how we observe it. The strange behavior of light illustrates a broader lesson about science, that understanding is not simply a matter of naming phenomena or memorizing equations, but of carefully observing, reasoning, and being willing to live with uncertainty and paradox. It is precisely this uncertainty that makes the study of light both challenging and exhilarating, because it reminds us that nature does not owe us simplicity or intuitive explanations, and that the pursuit of knowledge is not about achieving comfort, but about confronting reality honestly, even when it contradicts expectation. By grappling with the confusing and counterintuitive behavior of light, we learn to cultivate intellectual humility, curiosity, and creativity, recognizing that every measurement, every interference pattern, and every photon interaction is a clue pointing toward a deeper understanding, and that progress in physics often comes not from immediate clarity, but from the patient and rigorous exploration of phenomena that resist easy description. Light, in all its strangeness, becomes a teacher, showing that the universe is far richer and more subtle than our senses suggest, and that real understanding requires both imagination and disciplined reasoning, an openness to paradox, and the courage to admit that even what seems obvious may conceal layers of complexity that continue to inspire discovery. In this way, the study of light is not merely a topic in physics, it is a model for how to approach knowledge itself, demonstrating that confusion is not a failure, but a signal that we are probing the boundaries of understanding, and that the thrill of discovery lies in exploring the unknown, asking better questions, and marveling at the extraordinary intricacies of the natural world. Light is one of the most familiar aspects of our lives, yet it is also one of the most perplexing, because the deeper we look, the stranger it becomes, revealing behaviors that defy ordinary intuition and challenge our assumptions about reality itself. At first glance, it appears simple. It travels in straight lines, illuminates objects, reflects, refracts, and allows us to see the world. We have built entire technologies around it, cameras, lasers, fiber optic networks, and we describe it with waves or particles, giving the impression that we fully understand it. Yet experiments reveal that light refuses to fit neatly into either category. In some situations, it spreads out, interferes, and produces patterns that only make sense if it behaves as a wave. In others, it transfers energy in discrete packets, colliding with matter as particles, demonstrating a duality that resists simple explanation. This duality is not a mere curiosity. It lies at the heart of modern physics and continues to baffle even the most brilliant minds, illustrating that our everyday perceptions cannot fully capture the way nature operates. Phenomena like the double-slit experiment show that light can behave in ways that seem contradictory, producing interference patterns when unobserved, but arriving in discrete impacts when measured directly. Moreover, light's behavior is sensitive to conditions, interactions with matter, and the observer's frame of reference, meaning that reality itself appears linked to how we measure and interpret it. Understanding light, therefore, is not about memorizing definitions or equations, but about cultivating careful observation, critical reasoning, and the willingness to embrace confusion as a guide rather than a barrier. The strangeness of light is a lesson in humility. It reminds us that the universe does not owe us simplicity, that nature operates according to principles that can seem counterintuitive, and that real understanding requires patience, experimentation, and an openness to being challenged by phenomena that resist immediate explanation. By confronting this mystery, we learn that knowledge is not a collection of tidy answers, but a process of inquiry, reflection, and exploration, and that even the most familiar aspects of reality can surprise and inspire when approached with curiosity and rigor. The continued puzzles of light teach a broader lesson about the nature of scientific discovery and intellectual growth. Even centuries of study have not resolved every question, which shows that the pursuit of knowledge is not about achieving certainty, but about embracing the process of inquiry. By observing light and its paradoxical behavior, we learn that questions are more valuable than easy answers, and that confusion is not a sign of failure, but a signal that we are probing the boundaries of understanding. For instance, phenomena like quantum interference, the dual nature of photons, and the way light interacts with matter challenge classical logic and force us to reconsider our most basic assumptions about the physical world. These challenges cultivate skills that extend far beyond physics: careful reasoning, imaginative problem solving, and the courage to confront uncertainty. They remind us that reality does not conform to human intuition, and that progress often comes from following the clues provided by experiments, even when the results seem strange or contradictory. Learning to navigate the mysteries of light teaches resilience in thinking, the value of curiosity, and the importance of remaining open-minded in the face of paradox. Every flicker, every photon, every interference pattern becomes not only a scientific observation, but a lesson in how to engage with the world intellectually with patience, rigor, and wonder. In this sense, the study of light is both a window into the universe and a model for learning itself, showing that the excitement of discovery lies not in immediate clarity, but in the persistent and thoughtful exploration of phenomena that challenge our expectations and expand our understanding of the natural world. Light is one of the most familiar phenomena in our everyday experience, yet it remains one of the most baffling when examined closely, revealing behaviors that defy ordinary intuition and challenge the foundations of physics itself. At first, it seems simple. It travels, illuminates, reflects, refracts, and allows us to see the world in color and shape. We describe it as a wave in some situations, explaining interference and diffraction patterns, and as a particle in others, accounting for the way it transfers energy in discrete packets called photons. Yet neither description fully captures its true nature, and this duality lies at the heart of the mystery that continues to intrigue and challenge physicists today. Experiments like the double-slit experiment demonstrate that light can produce interference patterns when unobserved, behaving as a wave, but when measured directly, it arrives in discrete impacts like a particle. This behavior is not a flaw in the experiment, nor a trick of observation. It is a fundamental property of nature, showing that the universe operates in ways that resist the simple logic of our everyday experience. Light's behavior also depends on context. Its interactions with matter, the conditions under which it is observed, and the reference frame of the observer all influence what is measured, revealing that even something as familiar as light cannot be fully understood without considering the deeper structure of reality. This challenges our intuition and forces us to confront the limits of common sense, teaching that true understanding requires careful observation, critical thinking, and the willingness to embrace complexity and uncertainty. The study of light demonstrates that questions are often more valuable than immediate answers, because the universe does not always conform to expectations, and the pursuit of understanding is a journey rather than a destination. Light continues to confuse physicists, not because we lack tools, but because reality itself behaves in ways that are subtle, counterintuitive, and sometimes contradictory. The dual nature of light, the phenomenon of quantum interference, and its interactions with matter illustrate that what we perceive as straightforward can conceal deeper complexity. Accepting this is not discouraging. Rather, it is liberating, because it encourages curiosity and intellectual humility. Confronting the mysteries of light teaches that confusion is not failure, but a signal that we are probing the edges of understanding, that we are grappling with phenomena that demand new ways of thinking, and that progress in knowledge comes from asking sharper questions and exploring the unexpected. By studying light in this way, we cultivate skills beyond physics, resilience in reasoning, patience in observation, creativity in problem solving, and the courage to engage with phenomena that resist easy explanation. Every experiment, every photon detection, and every interference pattern is not just data, but a lesson in how to approach the unknown with rigor and imagination, showing that the process of inquiry is as important as the results we obtain. Ultimately, the mysteries of light illuminate broader lessons about the nature of reality and the way humans pursue knowledge. Even centuries of investigation have not fully resolved its paradoxes, demonstrating that learning is not about memorizing answers, but about developing the capacity to question, reason, and think critically. Light teaches that reality does not conform to intuition, and that the universe often operates according to principles that defy expectation, requiring observation, experimentation, and imaginative reasoning to understand. Its duality, interference, and counterintuitive interactions with matter illustrate that confusion is a necessary companion to discovery, and that embracing uncertainty is essential for intellectual growth. By engaging honestly with what we do not understand, we learn to cultivate curiosity, patience, and wonder, developing the mental tools necessary to explore not just light, but the deeper complexities of the natural world. The study of light becomes a model for learning itself, a reminder that the thrill of discovery lies not in immediate certainty, but in persistent, thoughtful exploration, in grappling with paradox, and in finding insight in the behavior of a universe far richer, stranger, and more intricate than our senses alone can reveal. Light is one of the most ordinary things in our lives, yet it is also one of the most extraordinary when examined closely, because its behavior challenges everything we think we know about the physical world and exposes the limits of human intuition. We experience light constantly. It illuminates our surroundings, allows us to see color and shape, and enables life itself. But these familiar effects hide a deeper reality that defies simple explanation. Experiments show that light behaves both as a particle and as a wave, a duality that is fundamental to its nature and that has puzzled scientists for generations. When light passes through narrow slits, it creates interference patterns characteristic of waves, yet when observed or measured directly, it appears as discrete packets called photons. This duality is not a trick or a measurement error. It is an intrinsic property of the universe, revealing that phenomena do not always conform to common sense or everyday logic. Even more, light's behavior depends on context. Its interactions with matter, the observer's frame of reference, and the conditions under which it is measured all shape the outcomes we observe. This means that reality itself is intertwined with how we study it, and that understanding light demands not only careful observation, but also the willingness to accept that the universe operates in ways that can appear contradictory from a human perspective. The familiar flow of photons from a source to our eyes is only a surface appearance. Beneath it lies a world of patterns, probabilities, and principles that continue to challenge the boundaries of knowledge. The persistence of light's mysteries highlights an essential truth about scientific inquiry, that confusion is not a failure, but a sign of engagement with nature's most subtle phenomena. For centuries, scientists have studied light, measuring it, modeling it, and using it to build technologies from microscopes to lasers, yet no single description captures its full behavior. The fact that even the brightest minds encounter uncertainty when studying light teaches a valuable lesson. Reality does not guarantee that things will make sense in the way we expect. Light forces us to recognize that what seems obvious or intuitive may be incomplete or misleading, and that understanding requires both rigorous observation and the courage to embrace paradox. Experiments that reveal unexpected interference, diffraction, or particle-like behavior are not obstacles to knowledge, but gateways to deeper insight, showing that progress comes not from avoiding confusion, but from confronting it directly. By engaging honestly with light's counterintuitive behavior, we learn to develop reasoning skills, patience, and intellectual flexibility, qualities that extend far beyond physics and into every area of critical thinking and problem solving. The mysteries of light remind us that the pursuit of knowledge is not about certainty or simplicity. It is about curiosity, careful measurement, and the ability to persist when the universe does not behave as we expect. Studying light also illustrates the power of questions over answers, because the more we investigate, the more subtle and surprising phenomena we encounter. Questions such as how photons can interfere with themselves, how light interacts with matter in ways that seem paradoxical, and how the same entity can exhibit both wave-like and particle-like characteristics push the boundaries of human understanding and expand the way we think about the world. These questions encourage exploration, creativity, and critical thinking because they cannot be resolved by rote learning or memorization. They demand that we test, observe, and reason carefully while remaining open to outcomes that challenge our preconceptions. In this sense, light is not only a physical phenomenon, but a teacher guiding us toward the habits of mind that characterize true scientific inquiry: patience, humility, rigor, and the ability to see beyond appearances. By wrestling with its mysteries, we learn that the pursuit of knowledge is an active, ongoing process, one in which questions are more illuminating than final answers, and where curiosity is more valuable than certainty. Ultimately, the strange and elusive nature of light offers lessons that go far beyond physics, because it teaches us how to engage with the world intelligently and creatively. Its duality, interference patterns, and dependence on observation demonstrate that reality does not conform to intuition, and that understanding often requires grappling with phenomena that appear contradictory or paradoxical. Accepting that light continues to confuse even the most accomplished scientists encourages intellectual humility and motivates lifelong curiosity. It shows that confusion is not a failure, but a signal that we are on the frontier of understanding, and that exploration is more meaningful than certainty. By embracing the mysteries of light, we cultivate critical thinking, imaginative reasoning, and the resilience needed to navigate complexity in any field. The study of light reminds us that the universe is far richer and stranger than it appears, and that the joy of discovery comes not from simple answers, but from the courage to question, the persistence to investigate, and the wonder that arises when we glimpse the extraordinary subtleties of reality hidden within the ordinary glow of the world around us. Light is one of the most familiar and seemingly simple phenomena in our daily lives, yet the closer we examine it, the more mysterious and counterintuitive it becomes, revealing behaviors that challenge our intuition and stretch the limits of understanding. We see it every day, experience it as brightness, color, and warmth, and assume that it behaves in predictable ways. We measure it, model it, and use it to create technology, giving the impression that it is fully understood. Yet experiments reveal a reality that defies these assumptions. Light behaves both as a wave and as a particle, sometimes spreading and interfering like a wave, sometimes transferring energy in discrete packets called photons, in ways that make sense only in the context of precise measurement and rigorous theory. This duality is not a flaw or a trick. It is an intrinsic property of the universe, demonstrating that reality does not always conform to human intuition. Even the simplest phenomena, like the travel of a beam of light, contain patterns and behaviors that resist conventional explanation, showing that the universe is far more subtle than our senses suggest, and that observation alone is not enough to fully capture its essence. Understanding light requires careful experimentation, imagination, and the willingness to confront uncertainty and apparent contradiction, teaching the broader lesson that true understanding is a process, not a final answer. The peculiar behavior of light illustrates an important principle about the nature of scientific inquiry. Confusion is not a sign of failure, but a signal of engagement with the deep complexities of reality. Light continues to puzzle physicists even after centuries of study, reminding us that the universe does not guarantee simplicity or intuitive clarity. Its wave-particle duality, interference patterns, and the dependence of its behavior on observation or measurement challenge assumptions and force careful critical thinking. Rather than being discouraged by the strangeness of light, scientists learn to embrace it, using experiments to probe nature and to gradually develop models that explain its behavior in specific contexts, while recognizing that no single description captures the whole truth. In this way, studying light cultivates intellectual resilience and humility, showing that inquiry requires both patience and courage, and that progress comes from engaging directly with phenomena that defy expectation. The questions raised by light are often more valuable than the answers, because they push the boundaries of understanding and invite deeper exploration. How can a single photon interfere with itself? How can light exhibit properties of both waves and particles? How does its behavior change depending on interactions with matter or the frame of reference of the observer? These questions cannot be resolved through memorization or intuition. They demand observation, experimentation, and imaginative reasoning. By wrestling with these puzzles, learners develop skills far beyond physics. They cultivate critical thinking, creativity, and the ability to hold seemingly contradictory ideas in mind without collapsing into confusion. The process of studying light becomes a model for learning in any domain, demonstrating that curiosity, persistence, and rigorous analysis are more important than tidy or immediate answers. Furthermore, the study of light demonstrates that reality does not conform to human expectations, and that understanding often requires grappling with paradox and uncertainty. Even when experiments and measurements produce consistent, reproducible results, the underlying nature of light continues to resist simple description, revealing that knowledge is provisional and exploratory rather than final. Engaging with these mysteries encourages the mindset of a true learner, questioning assumptions, examining evidence, and thinking flexibly. It teaches that progress comes from sustained attention to detail, openness to new ideas, and the willingness to revise understanding in light of new observations, rather than clinging to what seems obvious or convenient. Light's strange and beautiful behaviors illustrate that complexity and subtlety are not obstacles to understanding, but essential features of reality that challenge us to grow intellectually. Ultimately, light serves as a profound teacher, not just of physics, but of how to approach knowledge, inquiry, and the unknown. Its duality, interference patterns, and sensitivity to observation demonstrate that reality is richer and stranger than our everyday perceptions suggest, and that learning requires engagement with phenomena that challenge intuition. Accepting that light continues to confuse physicists is an invitation to cultivate curiosity, humility, and resilience, and to understand that the thrill of discovery lies not in immediate certainty, but in the process of exploring, questioning, and reasoning. By embracing the mysteries of light, we learn to value questions over answers, to see confusion as a guide rather than a barrier, and to approach the universe with imagination, rigor, and wonder, recognizing that even the most ordinary phenomena can reveal extraordinary truths about the nature of reality. The study of light reminds us that the universe is far richer and stranger than it appears, and that the joy of discovery comes not from simple answers, but from the courage to question, the persistence to investigate, and the wonder that arises when we glimpse the extraordinary subtleties of reality hidden within the ordinary glow of the world around us.